Good afternoon. Let me know in the chat of the webinar if you cannot hear me or if you cannot hear the panelist. So good afternoon to everyone and welcome to the first ETIP SNET national webinar co-organized by the ETIP SNET and the technology platform Smart Grids Austria. I'm Rémi Landau. I'm a member of the ETIP SNET support team, and I would like to thank you all for your interest in participating in this webinar. And I hope that the presentations and discussion will be as useful as possible for all of you. I would like to remind that these webinars aim at sharing information, recommendations, best practices between national stakeholders, including national platforms, ministries, funding agencies, and so on, and research organizations, and also at discussing the complementarities, synergies, and overlaps between, on one side, the research and innovation strategy and implementation at EU level, and on the other side, the research and innovation strategy and implementation carried out at national or regional level. So to start the webinar, let me just present you the agenda. So to start, I will give you some information about the webinar and how it will take place. Then we will have a presentation of the ETIP SNET scope, activities and objectives by Nikos Attiarghiriou, ETIP SNET Vice Chair. After that, we will have a presentation of the technology platform Smart Grids Austria by Valerie Reif. And then the presentation of the IES Integrating the Energy System project by Valerie Reif and by Matthias Frohner and Stefan Sauermann from the University of Vienna. And we will end the webinar with questions and answers sessions that will last around 10 minutes until the end of the webinar at 4 o'clock. And I would like to remind you that the webinar will be recorded and that the recording of the webinar as well as the slides presented today will be made available on the ETIP SNET website and should be uploaded early next week. So all the content and the support documents will be public. Before starting the webinar, I would just like to say a few words about your contribution and how you can interact with the panelists and the speakers during this hour. So just for you to know that you are muted so far, so you cannot ask direct questions to the panelists. I will give you access and I will give you permission to speak when you have questions to ask to the speakers. You have a control panel with different features and options that you can see to fix your audio and to ask some questions. If you cannot see the control panel, please click on the orange arrow that you can see at the top of the interface. You will have the opportunity to ask questions to the speakers. So first, there will be written questions. So again, in your interface, you have the option to ask written questions. Please do so. And when the presentations, after each presentation, we will ask the questions to the speakers and they will try to reply. And at the end of the session, for the Q&A, you will have the opportunity to ask questions directly to the speakers. And to do that, you will have to raise your hand. So you can see on the interface that option to raise your hand to ask the speakers. You raise your hand and then I will give you the possibility to, I will unmute you so that you can ask your question. And I will give the floor to the panelists. Now I will give the floor to Nikos Attiarghiriou, Vice Chair of the ETIP SNET, who will present you the objectives and activities of the ETIP SNET since its creation 2 years ago. Nikos, you should be able now to pass your slides. Thank you.
Okay. Hello, good afternoon, everybody. I'm going to give you an overview of the European Technology and Innovation Platform for Smart Networks for Energy Transition. It will include some history and also our present activities and our future goals. In fact, what determines our work is the European Research and Innovation Energy Policies. And these are defined by the SET plan, the 2008 goals, the binding goals of 2020, which means reduction of greenhouse gas emissions by 20%, 20% renewable energy and 20% energy efficiency, which has been followed in 2014 with the towards an integrated roadmap that looks at individual technologies, how they will be integrated in the energy system, and has set policy challenges like consumer at the center, energy efficiency, system optimization, and supply of technologies, and which has also set not binding targets of 40% reduction of greenhouse gas emissions, 27% of renewable energy in the total energy, which means much higher in the production, electricity production, and 27% of energy efficiency. And then we have recently the Energy Union, which has priorities: energy security, solidarity and trust, a fully integrated European energy market, energy efficiency, which means moderation of demand, transition to a low-carbon society, decarbonization of the economy, and research, innovation and competitiveness that has been put as a very important priority. And in that aspect, we can see the key actions of the plan, which are the 10 key actions, starting with the performant renewable technologies, integrating the system, reduction of costs of renewable technologies, new technologies and services for consumers, the security of energy system. This is of particular importance for the ETIP SNET, where we mainly focus. Then we have the new materials and technologies for buildings, energy efficiency for industry, competitiveness in global battery sector, e-mobility and renewable fuels, set up of research and innovation activities applying to carbon capture and storage and CCU, and maintain safety level and improve efficiency in nuclear energy. So in the past, we had a number of initiatives that built an advisory framework for the European Commission. Now we have integrated these activities that were the EGI, grid and grid plus storage, that were mainly operators initiatives, and the ETP smart grids. So we have now a new focus and on innovation, implementation, and sector coupling. So this has formed now the ETIP SNET, and the main objective is to address the innovation challenges in energy system and market evolution necessary for achieving climate protection, renewables integration, affordability and security of supply beyond smart electricity grids. So a very important difference from the previous initiatives was that now we look at the whole energy system and interaction with other energy carriers, not only electricity. So the main objective of ETIP SNET is to address the innovation challenges in energy systems and market evolution necessary for achieving climate protection and renewables integration with affordability and security of supply beyond smart electricity grids. This is, and let's now see what is the ETIP SNET's mission in this transition. So we intend to set out a vision for research, development, and innovation for smart network energy transition, vision, to prepare and update the strategic research and innovation roadmap, to report on the implementation of research and development innovation activities at European, national, regional, and industrial levels, to provide input to the set plan Action 4, which addresses the technical challenges raised by the transformation of the energy system. And let me remind you that this Action 4 speaks about the resilience and security of energy system. Identify innovation barriers related to regulation and financing. Developed enhanced knowledge sharing mechanisms that help bring research, development, innovation results to deployment, and prepare consolidated stakeholder views on research and innovation and European energy policy initiatives. This is very important because what we want to do is to provide a consolidated view of all related stakeholders, which are these are the main stakeholders which really involve TSOs, transmission system operators, DSOs, distribution system operators, national representatives, research and academia, storage, consumers, thermal flexible generation, renewable energy generation, ICT, network and software providers, equipment manufacturers, not ICT, and interface to other energy carriers, heat and transport and gas, and regulators. So this is the whole view of stakeholders that ETIP SNET aims to integrate. And our organization involves a governing board, which is assisted by the ETIP SNET Secretariat, and this is under the supervision and support of the European Commission. We have 30 members representing European stakeholders, and EXCO consists of 9 members. And then very important, we have experts of working groups, which is, you will see later, we have a good representation from various experts in Europe, and the national stakeholder coordination, which are ministry representatives, funding agencies, regulators, national platforms, etc. And this all activity is helped by ETIP SNET Secretariat, which is supported by the Intensives for You coordination project, funded by the European Commission, by Horizon. So we are organized in the following 5 or 6 working groups. And working group 1 speaks about reliable, economic, and efficient system integration, storage technologies, flexible generation, digitalization, innovation, how we implement innovation in the business environment, and finally, national stakeholders coordination group. In short, working group 1 is the working group that sets the main requirements of the future efficient smart grid. And then this is supported by the various flexibility options, which include storage, flexible generation, customer participation and digitalization. And then working group 5 wants to see how innovation can be implemented in the business environment. Finally, we have an important collaboration and help with the national stakeholders coordination group. So working group 1 is overall energy system optimization and affordable investment operation costs. Working group 2 is focused on storage technologies and sector interfaces. So again, this is how storage can provide flexibility to transmission and distribution of electricity. Working group 3 deals with flexible generation, both renewable and thermal. Working group 4 deals with digitalization of the electricity system and how customer can participate, facilitated by the new information and communication technologies. Innovation implementation in the business environment is how Group 5 looks at research and innovation projects and promotes their uptake by the industry. And finally, we have the National Stakeholders Coordination Group, which is the exchange platform for national research and innovation stakeholders in the areas of our interest. This is how we can view the deliverables. We have you have the current EC work program, which is we participate in the ECA consultation process. Then you have the ETIP SNET implementation plans of 3 years research and innovation needs. So every 3 years we update this. And you have also the 10-year research and innovation roadmap. So, and that's done by member states, experts working in the working groups of ETIP SNET, public consultation, regional workshops, and monitoring of the projects. And finally, we are now in the process of developing our vision for the long-term scenarios of 2030, 2050. That is already carried out by experts from working groups. These are the deliverables we have already provided. Also, including the ETIP SNET vision for 2030, 2050, which is planned for 2018. You already have delivered the January 2017, the final 10-year ETIP SNET roadmap for 2017-2026, an implementation plan from 2017-2020. Now we built a new roadmap from 2029, which is based on consolidation and balanced stakeholder viewpoints through regional workshops, also balanced stakeholder viewpoints through public consultation, and a monitoring review of national, European, international research and innovation activities. And for that, we need to access the coverage of the research and innovation activities by national and European projects. This is how the implementation plan is structured, the October 2017 implementation plan, which includes, as you see, the power transmission networks and the power distribution networks on the left side. You see the other energy networks, gas and heat on the right side. And then we have in the middle, and very important, the consumers connected at both transmission and distribution. You have the flexible generation, large scale, and also distributed, connected to the distribution network. And you have important contribution for storage in both transmission and distribution. And then this is organized in a number of horizontal activities, which include the high renewables and empowered end user energy systems, governance and market design, digitalization that really goes through all electricity network, through all energy network activities, energy system, interfaces with the other energy systems, between energy systems, and the improved components of the energy system. Now, very important, most important for ETIP SNET is the collaboration with national stakeholders. Our aim is to ensure consistency and complementarity between European research and innovation and national research and innovation activities and priorities. We want to know more about what happens in research and innovation at national and regional level in order to avoid overlaps between national research and innovation funding at EU and national levels and avoid duplicating work. And the activities we have for this is to create and coordinate and animate national stakeholders coordination group, providing a sounding board and exchange platform for national stakeholders in the area of energy system and network. Organize regional workshops. We already have organized in 2017 4 regional workshops of good success. We would like to monitor of research and innovation projects implemented at national level and organize national webinars in collaboration with national stakeholders. And this now comes today's activity, which is the organization of the first national webinar. And I'm really very happy, very pleased that we are starting this very important activity. Thank you very much for your attention.
Thank you, Nikos, for this very interesting and clear presentation. I would suggest to try another time to take a look at that ETIP SNET video that we tried to show you before. It should be working now. So let's try to watch it again.
Europe has started its energy transition, but what does this actually mean? Energy transition is about allowing renewables to become our main source of energy, while guaranteeing security of supply to all at an affordable price. This can be made possible by interconnecting our whole energy system, integrating novel storage technologies through a digitization of the entire system, and also by developing a genuine European electricity prices signal system. Sounds ambitious? Indeed, there are many unresolved questions. How do we provide reliable electricity when the sun doesn't shine or the wind doesn't blow? But also, how can we make internet-enabled apps control the energy provided, stored, and used remotely, and have a reliable and efficient system? Enormous challenges arise in terms of regulations, market design, affordability, and reliability. This is why research and innovation is key to achieving our energy transition. Within the Strategic Energy Technology Plan, the European Commission created the European Technology and Innovation Platform on Smart Networks for Energy Transition, a unique platform that gathers a variety of stakeholders in Europe to define the needed technology shift and market-based services. ETIP SNET prioritizes R&I needs based on defined visions of energy's future, but also building on Europe's strengths, like great products and excellent systems integration. Together, we can make Europe's energy transition a success by setting the right conditions to help European industry and research to innovate for the future energy system needed. What are we waiting for? Be part of the solution. Let's plan, innovate, engage.
All right, it seems that you were able to see the video that time. We are already a few minutes late, so I will move to the next presentation by Valerie Reif from the Austrian technology platform for smart grids. Valerie, you should be able to present and to move the slides. Please tell me if you have some issues with doing it. Thanks.
Okay, thank you, Remy. Good afternoon, everyone. My name is Valerie Reif, and I work for the Austrian Technology Platform for Smart Grids in Austria. I will be taking over for our Managing Director, Angela Berger, today, who unfortunately cannot be here. First of all, let me introduce you to my colleagues who are sitting right next to me right now. So we have Stefan Sauermann and Matthias Fohner, both from the University of Applied Sciences, Technikum Vienna. Stefan is an expert on e-health and a founding member of the organization Integrating the Healthcare System Austria, which we will hear about later today. And Matthias works as a researcher and senior consultant in the area of IT standards in healthcare. About today's program, I will very briefly talk about the activities of the technology platform, and then we will jump right to our main research project at the moment, which is called Integrating the Energy System, or in short, IES. So the technology platform was founded, yes, it works, was founded in 2008. And at that time, the focus was mainly to identify and define research questions in the area of smart grid. Since then, the focus has shifted a little bit towards a more political approach, and we more and more engage in discussions with policymakers, and we try to steer the discussions on regulatory issues towards a more innovation-friendly approach. I provided you with an overview of our members. Just for you to see. One of our main functions really is running and cultivating the smart grids network in Austria. And last year, we started publishing position papers and fact sheets on a rather regular basis. The topic of our newest position paper is battery storage in distribution grids. And I'm a little proud to say that it's also available in English, so you can download it if you're interested. The platform runs 3 big projects, the first of which was the Technology Roadmap Smart Grids Austria 2020. It gives an overview of the actual state of development and focuses on technologies and implementation steps towards a smart grid in Austria. Another initiative was called RASA. It's called Reference Architecture for Secure Smart Grids in Austria. And it was completed at the end of last year. And the objective was to design a holistic reference ICT architecture while considering resilience as well as safety, security, and privacy issues. And the third project, and the one that we want to talk about today, is called Integrating the Energy System, or as we call it, IES. So I'll hand over to my colleagues in a minute, but let me do the introduction first. So the objective of IES is to deploy processes to ensure interoperability of data exchanges in ICT systems in the energy sector. And maybe as a starting point, what is interoperability? So in layman terms, it is very often defined as the ability of systems to exchange information. But more important for us in the ICT sector is semantic interoperability. And semantic interoperability ensures that the precise format and meaning of exchanged data and information is preserved and understood throughout exchanges between different machines from different vendors. That is important, different machines from different vendors. And why is that important? If we put it very simply, and I think we all agree that we need an energy transition to happen. There's no energy transition without digitalization, and there is no digitalization without interoperability. A lack of interoperability is both a reason for and a result of market fragmentation. It perpetuates market fragmentation and it creates significant barriers to market entry, especially for innovators and SMEs. A conceptual approach to interoperability within smart grids has already been described by the European Mandate 490 that some of you might know already. Well, as we all know, the electric power system is characterized by great diversity and heterogeneity of systems. And this is also what makes it so difficult to state a consistent specification of requirements. So to cover the complexity, the mandate 490 developed the so-called use case methodology and also the smart grid architecture model, which you can see on the slide on the right-hand side. So both the use case methodology and the SGAM were developed with regard to the TOGAF, developed by the architecture development method defined by the Open Group Architecture Framework, which is also known as TOGAF. So in very short and simple words, the experts on the mandate, they defined how interoperability in a smart grid can be achieved. And that is by a 3-step process. And that's first, system specification, second, use of standards, and third, testing. So when we started our project 1.5 years ago, we looked at this process and we thought, well, you know, it looks like a really nice process, but it sounds rather academic. We desperately needed a best practice example. We needed someone who had already achieved interoperability in their sector. And then we started looking and we stumbled across the health sector. And this is where I hand over to my colleague Stefan, who is an expert in e-health and interoperability in healthcare. And I would kindly ask you to share your wisdom with us.
Okay, thanks Valerie for this nice introduction. So going back about 20 years, the same experience that we see now in the energy domain occurred in the healthcare enterprise. And you have the example on the screen about radiology workflows. So at that time, we already had standards like DICOM and other standards. And the requirement arose to connect other types of processes, not just the imaging, but also the administration, admission, discharge, which brought in a large set of standards that had to be integrated. And this caused a lot of problems because each standard is big and complex enough, and putting more of them into one single box with a lot of organizations and enterprises and vendors makes it horrible. So the solution was to found an organization to find a practical way to deal with this. Now, what are they doing? They are developing integration profiles. And the important thing is you have 2 large contributions. One is from the users who are applying those systems, and the other contribution comes from the manufacturers, the engineers who design those systems. And you need users to define what has to happen, what do we want to do, and the vendors will bring in the knowledge of how should this be implemented. And together we are coming up with what we call integration profiles that then describe how to implement a certain workflow using a large set of standards. And IEG has been doing that for a large number of domains in healthcare, including radiology, laboratory, and IT infrastructure, electronic healthcare records with great success worldwide. Now, the problem is, as you can see, we have a lot of boxes around here, and this is just a very simple description of a system consisting of a number of subsystems, large and small. And you have those red arrows that connect a system to another part of the system, and that's what we are basically talking about. So now what we're doing, we're introducing basic units of interoperability, and we call them actors and transactions. So what you're looking at is one single arrow, and you try to find out what that type of communication is, what's happening here between the two actors, and you then define this as a specific transaction. You provide a name and a number to it, and then you define how this should be implemented using a large and complex set of standards in a 20-page document, which everybody can read and use and implement. And that's exactly what IEG has been doing. And each vendor now takes these actors and builds them into their system so that then the transactions can get going. So in that way, you break it down into smaller pieces which are well defined and which can be handled, which can be implemented. Described in what we call profiles, integration profiles, and you can then in the last step you can then build systems. You can build those actors into those systems. You don't need to throw away the complete system. You can just change the interface. You build the actor into the system, which will then enable you to run the transaction between all others who want to communicate in a large system. And this is the approach of IEG. And we have been trying to apply this. We've been applying this for the energy domain, and Matthias can now explain to you what exactly that means.
Yeah, thank you, Stefan. Hello, welcome also from my side. Wish you all a nice afternoon. So, having heard about the latest history of medical IT and all the issues that arise with the distribution of systems in the field and the need to interact or to interconnect those systems and to share information, well, we can stretch this somehow to the issues and current challenges that we might find in the field of energy. For example, if you think of a use case or a scenario about the virtual power plant, where on the left-hand side you can see the different assets that might be connected, so wind turbines, PV panels, or battery or loads, they need somehow to be orchestrated and communicated, because in order to sell the energy, the VPP, so the virtual power plant operator, needs to know what is the forecast, what is the schedule of the devices, what is the current power consumption or power delivery or amount of power they are going to deliver, and need to sell it to the electricity market. On the other hand, he needs to communicate with the distribution system operator. So having this in place, you might find that many different vendors might be engaged in such a system or in a whole system, selling small pieces of hardware for wind turbines or developing an implemented software solution for the distribution system operator. In a perfect world, they should all be able to communicate with each other, because then we have the information where we need to have it, and we can take right decision on this information. Taking the idea from IEG, just having a look, okay, what is needed in terms of sharing data, we can think of, okay, we might define software entities as well. So these actors. On the left-hand side, we have the actors for the distributed energy resources. And in the middle of the screen, you can see one actor that might be implemented in a VPP operator. And with the red arrows, you can see the transactions, so the message flow that is needed in order to communicate data. And further on, we can think of implementing these software actors also at the market side or at the system operators. Defining here a lot of different interfaces, maybe using different communication standards. So there's a plenty to do for an implementer and also for the vendors. How can we now ensure somehow that all are doing the same thing? There I would like to show you the process, which is strongly aligned to the IEG process. You might think that the process starts in the left top corner, but maybe it's better to have a look here at the users' purchases, because in the very first place, the users are those who are defining what they really need. They are defining use cases, and based on these use cases, in our first step, IES, but further on maybe some spin-off, some organizations, some company, or not company, but some unit might think of, okay, having these use cases, what communication standards in place can we use in order to fulfill these use cases best? So taking the standards, but then further refine them in order to suit these use cases. Because the issue is, if you take the IEC 61850, there are thousands of pages, and there's a lot of optionality in there. But for a specific use case, you will be able to specify it and restrict the standard and put this into an integration profile. So a technical report specifying exactly what is needed to be implemented for the specific use case. Having this in place, implementers in the middle of the screen can take these integration profiles, develop and implement their systems and softwares, and in order to ensure that all this implementation process has been done correctly, they can assign themselves, the companies, to take part at a connectathon test event, where they then sit together with other vendors, other developers in a big conference room, testing the software against each other in terms of sending messages from A to B and having a look if these interoperability issues are solved. But I will come to this back later on. So one of the goals is we need somehow this integration profile. So this technical framework specifying what to do for a specific use case. Because in the end, this is a document that is shared with the community, and the community needs to implement it. And for this technical framework, there's also an idea about the structure, how to structure it, because one issue is that this document might be of high interest for the management boards or people on the management layer, deciding, okay, is a certain use case realistic to be implemented for our own software solution? Is this something a company, a business want to stress for? And on the other hand, we need to provide the specification for the engineers implementing the software. So for the structure of such a document, we're starting on the right-hand side and top right picture. You see, we first think about a certain business domain, for example, about the energy domain, and then have technical frameworks developed. One would be, back again to our example for the VPP operator, or for the virtual power plant, and then discussing in volume 1 of this technical framework, what is the business all about? What are the different types of virtual power plants that might be implemented? And based on this business overview, the business use cases are derived. And such a business use case somehow depicts interoperability issues. So really one issue where we need to communicate with different systems, and there's a high probability that we might face interoperability issues. In order to get these interoperability issues addressed, we define then single integration profiles for the single interoperability issues. And there we start defining the actors you have seen on the previous pages and the transactions, so the errors linking the actors together. This is then should be also, as I mentioned, readable for higher layers, not too technical, just to give an idea what is the possibility, what are the features of a virtual power plant, and what are the business use cases, and how they might be solved on a, well, not too technical layer. Since this is all about interoperability and the message exchange, then with volume 2, the really hard stuff starts. We start to define or to specify the transaction. So meaning, what is really the content which should be moved from A to B? How is the semantic? How is what term nomenclature might be used? What standards are used for specific message encoding? What is the sequence of messages? What is the trigger event for a message? And of course, including security considerations. On the left, you're finding the third bullet point is very important. So these technical frameworks, they are not dealing with defining new standards, just taking already existing standards and try to restrict them in a way that is really, in the end, implementation A and implementation B have the same interface. In the lower right corner, you can see such a short diagram showing actors and the transactions. For example, we have here taken from the 61850 the logical node functional schedule. So we have an FSCH encoder, a functional schedule encoder, as one actor, handing over the outcome of this software module to a transaction initiator, which is really then interfacing on the right side the transaction responder, which might be implemented in a distributed energy resource. So since this technical specification, this profiles are really high importance, because this is where we all define and specify everything. And now the question is, who is we? In the end, it should not be only the project IES. We just implement the first ideas for proof of concept, but in the end, it should be the community. And for the community, this is now a process from IEG. You can see that on a nearly yearly routine, the domain secretary is asking the community, is there any need for are there any new use cases? Are there some interoperability issues we need to solve as a community? And then over different committees, the decision is made if it's worth to define a profile, if there's really a need from different vendors. And then in the end, what is important in the end, to define a profile. It's somewhere here, the profile, it will go back then for a review process with the community. And after the community says, okay, this profile seems to be feasible, the standards described there are really used, then it will be released for trial implementation. So implementation is not everything. Well, maybe I'm going to show over this picture. This is just one thing to discuss a certain use case on higher layers, so UML diagrams depicting the different entities that are involved in a domain, and also displaying already the interoperability issues in terms you see when a communication is needed between different entities. And here again, a more detailed and technical approach again with actors and transactions. So this was one example based on the virtual power plant where we thought of, okay, let's try this approach, defining some actors and some specifications for the transactions. But in the end, it's all about that the software is really functional, really fulfilling in purpose, and can be implemented and can be used in the field. So after the specification, after the implementation, the next big step, of course, is interoperability testing. And for interoperability testing, the IEG hosts on a yearly basis Connectathon, a huge test event where the vendors can subscribe, meet all physical together in one place, and really try if their single actors communicate according to the way it is described in the specifications, so in the technical frameworks. Besides, so on the left-hand side, you see the software under test from vendor A, and on the right-hand side, the software from vendor B. please consider that this also might be only a prototype status of the software. This is one idea of these connectathons, that the experts and engineers can somehow share and solve some common issues. But in the end, they can test the software based on these protocols, on the one hand against the specifications, so some kind of conformity tests, and on the other hand, to test again really the software under test from a different vendor, so interoperability tests. And for these test events, there is an open source test engine, a test platform, the Gazelle from IEG, which we also want to use for our project IES. And therefore, and in the end, what would be the final, or what would be one outcome or one goal from the different vendors is that if they succeed in the tests defined by IEG, the result will get published on the result database of IEG. And this is quite of interest for procurement processes, because it's open to public, and an interested company can have a look which software vendor, which company has taken part in certain interoperability tests and state that their software really fulfills these interoperability requirements. So if they want to buy something, they can check this result database and find evidence that they solve these interoperability issues. And for the upcoming European Connectathon, which will take place in The Hague in middle of April, we, as a project IES, we will be part of this Connectathon, and we would be really glad if we find some interested people, some organizations, because we want to, or we're going to test the first profiles from the virtual power plant domain based on IEC 61850. And I would like to invite all of you to come there, either with your software, test it, or come there in person, discuss further issues of interoperability in the energy domain. Yeah, with these words, I would like to hand over to Valerie again.
Thank you, Matthias. I will take 2 more minutes to tell you, now that you've heard all the technical details, about the greater vision behind the project, which we call IES Europe. So, as you've heard, right now we're a research project, but in the future we would like IES to become its own independent European organization, just based on the model of the health sector. And we truly believe as a project team that that would be in the interest of Europe, as it fosters both the digital single market as well as the internal energy market. And in that respect, we are evaluating right now how we can find synergies with the many European interoperability initiatives across sectors that already exist, such as the European Interoperability Framework or all the others that I mentioned on the slide. So as you can imagine, the organization of a test event as the Connectathon, like Matthias explained to you, adds up to a huge organizational effort. And what we have learned from the health sector is that you really need a community. You need a community that is eager and willing to take on this great task, because they feel that this goal of achieving interoperability is of significant value, not only for their own work, but also for the progress of the entire industry. So we will take the Connectathon in The Hague as the starting point for building such a community in the energy sector. And what we look for at the moment are early adopters who acknowledge the need for interoperability, and also who share their real-world interoperability pain, let's put it like that, with us. We need industry representatives to work with us and to support us in the development of new profiles. And as for all the representatives of technology platforms and tech clusters among you, we also need IES contact people in other European countries, and of course, opinion leaders who multiply the vision. And so in short, I would again like all of you to join us in The Hague at the Connectathon. And I would also, like, for our initiative to steadily progress, I would also urge you to really share your interoperability challenge with us, and to support us in developing new profiles that fit your real-world interoperability needs. And with that, Stefan, Matthias, and I would like to thank you for your attention. And I'm sure you have many questions, and we look forward to answering them. Thank you.
Thank you, Valerie. We already have some questions for you. The first one is how can we join and possibly take part to further tests?
Well, you have seen we have been really defining the virtual power plant very deeply. Our next goal would be the communications from out of the virtual power plant to the real world. So that's what we target in the next time, or probably in summer. And we are very open to anything that you direct us. We are not wanting to force anything on you, because it's everybody else who should do this, and it's a group decision. So we are asking you, actually, what do you need?
Okay, thank you. We have another question. What about the compatibility of future smart meters and devices?
Well, they are one part which needs to be discussed. Smart meters are very important, and there are many discussions about smart meters, and that's what we noticed in the project. It depends, whoever you talk to, you will get a completely different view of the role of the smart meter. So looking at that, we realized that they will be part of the game. We will define profiles and transactions for those smart meters. A lot has already been done. Yes, we have to sit together and go on and discuss how this should be assembled into a whole large picture.
Thank you. I will ask you a few more questions. We have a question from an energy engineer student asking, in the IES project, is it mainly ICT engineers required or also electrical and mechanical engineers?
Well, just on the perspective of IES, IES deals with interoperability issues in the field of ICT. So sharing information and not on the operational level. Of course, as a whole, if you have the really hardware distributed in the field, an ICT engineer is nothing alone. Just providing maybe the software and hopefully with a standardized interface. But what happens after there, this is totally outside the scope here at the moment from IES. So electrical engineers, welcome to join us, provide their ideas, tell us what is really possible, what will be possible in the future, what is needed, bring in their own perspective. But here, at this point in time, we're dealing with interoperability issues just on the informational level.
Okay, thank you. Let's go to the next questions, because I still have some to ask you. Are there concrete software pieces available for download and learning?
This is a very valid question. We have, at the moment, we are preparing for the Hague also some showcases, and based on these showcases, we will hand out some demonstrators, so some software packages that can be used as a best practice example, or at least as an example that has been developed from our project partners. What we can offer right away or quite easily is a test point for an endpoint for testing. So having in place the idea of the virtual power plant, we have a VPP operator software solution which is accessible over the internet. So there you can have a look at our specification, implement our specification, and see if this VPP operator actor is really reacting to your queries or to your messages. And we also have in place one software actor emulating or simulating the behavior of an power generation. What else is feasible to have a look on is OpenMOOC as a framework supporting different communication standards. And I think this is also quite valuable to have a look there on the OpenMOOC.
Okay, thank you. I have 3 last questions before ending the webinar. The first one would be, what is the expected timing for the next steps for the project?
Well, we will be, as we already explained, we will be participating in The Hague in the Connectathon, so that will be on the technical side. And on the organizational political side, we're looking deeply into synergies with European initiatives. So we are also looking at synergies with the SET plan and also SET plan implementation plan. That is also among the next steps. But on the technical side, it's really the Connectathon. Oh, yes, and also, of course, the development of new profiles. Yeah.
And how many people are expected to come to Den Haag meeting?
6,000.
At least.
Impressive.
The Connectathon typically has about 300 individuals from 80 companies who are doing testing in the healthcare domain. So this will be a large crowd. And around that, there will be a lot of attendees coming, discussing many other aspects of interoperability, because this takes place within an event they call the vConnect. And so you will be highly welcome, and we will have a series of workshops explicitly on energy. And you will definitely not be alone. There will be attendance from the higher European layers, from companies, from academia, all over the place.
Okay, thank you. There is a direct question from Bertrand Wauquiez. Bertrand, you have the floor if you want to ask your question.
Yes, thank you. Can you hear me?
Yes, perfect.
Yes, good afternoon. Thank you for all this interesting presentation. Could I just come back a little bit to the expected timing for the next steps? Well, I understand that the next step will be the show in The Hague in April, but I would like to know a little bit more about the expected timing for the next steps, integration, for example, with other possible standards or protocols in Europe, or when can we expect to have something integrated, let's say, at the European level? Are we talking about, for example, 5 years, 10 years? Any idea of such a timing, please?
Well, comparing from the energy domain, IEG started in the 1990s, and we can now see a complete coverage of most of the healthcare domain. And you can see many countries who are rolling out IEG conformant healthcare records nationwide, and Austria is one of them. And you can imagine that the complete change in industry doesn't occur over 6 months. So this is not just an IT problem. You also have market problems and regulatory problems. And so this is not to be dealt with. We are not going to deal with this alone. So what you can expect is that over the next 15 years, a lot is going to happen. And then you will see large systems integrated on a very operative level.
Okay, thank you. I will ask you a few more questions. Still about the meeting in Den Haag. Can you give examples of who will be coming for sure, such as company names, etc. If you have some you can mention.
Like from the healthcare domain, you have General Electrics, Siemens, Tierney, Toshiba, I would believe, a lot of imaging companies, Philips, you name them. We can easily prepare a list for you, and you can look that up at the Connectathon results database. So the medical device vendors are all represented, as well as the main software vendors globally.
Okay, great. And the last two questions. First, if the team is trying to facilitate energy system integration, just focusing on the technology, how can they make sure that data privacy of the consumer is addressed? The data privacy of consumer is addressed.
Are we speaking here about a technical issue or from legislation? Because from a technical, maybe from both sides, if you want to compare it with medical communication, there is the same issue of data privacy and all the security stuff. So on the technical basis, there are ways, at least from the medical IT, that have been proven to work in the last years. The question is if they can be taken one-to-one for this energy communication, but at least there are some ideas. On the legislative side,
well, in the healthcare record, this has been solved. We have to definitely solve this in the energy domain as well. And this has also been recognized by the European Union, and that's the main point. The European Interoperability Reference Architecture covers the 4 layers of organizational, legal, technical, and semantic interoperability, and that's exactly the exercise we have to start. We have to look at the law, at the choices of our citizens in Europe, in the member countries, and of course, industry also has to join this discussion. We have to decide which security issues we have, and we have shown in healthcare that it is possible to implement every requirement that has been raised in the Austrian healthcare record. In healthcare, and I'm sure in industry, this will also be possible to use the up-to-date security methods and technologies to make this secure.
Okay, thank you for these clarifications. One last question. Are you looking for partners for joint proposals to answer some ICTH 2020 calls in 2018?
Well, we could definitely look into this, but we, as a research project, we have limited resources, so we would definitely need the partners who are willing to do the work with us. This is very important, but we can talk about this. Yes, definitely. So if you're interested and if you want to start a new project, please talk to us. Yeah.
All right. Your contact details are at the end of the slides, I think.
Yes, they are.
Slides that will be uploaded on the ETIP SNET website as soon as possible. And one last question, this time this is really the last question. Is there a plan to have part of this initiative to be funded by H 2020 or by other similar programs?
Well, as I just said, we're looking into this, but we are preparing the Connectathon right now, and we're trying to find new partners to do it. So alone we will not be able to do it, but if we have partners from other countries, especially for the H 2020 call, then we are definitely interested in looking into it. Let's put it like that.
All right, thank you. That was the last question. The webinar is now coming to an end. I would like to thank you all again for joining the webinar today. Special thanks to the panelists for their very interesting presentations and for the support and involvement of the technology platform Smart Grids Austria. I would also like to inform you that the next national webinar will be co-organized with Think Smart Grids, the French national platform for smart grids, probably in March. There will be more information published about this webinar on the ETIP SNET website. So I recommend you to take a look at the website. Thank you all for participating, and good afternoon to everyone.
Thank you.
Bye.